Well, welcome everyone. Is it okay? Yeah, better. So how's the day been so far? Good. Awesome, thank you. So in this session, what we're going to talk about is the two announcements which you saw in keynote today, which is Amazon S3 Select and Amazon Glacier Select. And then we're going to talk about that. You listened to Andy talk about in the keynote that how these features can help you run, make a data lake effective in a more effective manner based on the existing technologies. You need to get the performance improvements. So what we're going to talk about in the session is first introduce you to these two features which we announced today in the keynote, Amazon S3 Select and Amazon Glacier Select. In a very brief, describe what they do, how they work, how they operate, and then do a deep dive into some of the use cases in which these features apply and how they work. So we're going to also do demo in most of the use cases, say that this is the use case and how these demos or how these technology actually operate. So with that, what you heard Andy talk about in the keynote today is that many customers today are choosing to use S3 as a data lake. They are choosing S3 to use as a data lake because of the feature it provides for you to effectively manage, operate, and store the data. So if you think about it, for example, within S3, when you put data, we store the data in a minimum of 3 facilities or 3 AZs, which means that you get 11 nines of durability from your data set. Not only that, your data you get the throughput, but depending on, irrespective of how much data you're storing, well, you can use the same data set, you can use the same construct within S3 to query the data using a 10-node cluster, a 100-node cluster, a 1,000-node cluster. You can operate the same data set at a terabyte level, petabyte level, or exabyte level without having to do any sort of management, any change in architecture, or any sort of like external steps in there. But if you even think about that from an encryption perspective, for example, you have a choice of 3 encryptions. You could choose to encrypt data, or S3 do the encryption for you. You could choose to have the encryption key being stored in AWS KMS, and S3 use those keys to encrypt your data, which means that you are in control of the keys. Or in cases, you can also choose to encrypt the data on the client side you're putting in S3. And all of these work with S3. Or if you think about auditing, for instance, that you can use CloudTrail data events to figure out who is accessing your data, when they're accessing it, how they access the data sets. Or think about Amazon Macie, which allows you to protect, discover, and find sensitive information sitting in S3. But not only that, Amazon Macie also allows you to figure out that has there been any anomalies in your object access patterns. It uses the CloudTrail data events and machine learning to understand that this was your normal access patterns, but now they see a change in behavior, and it can alert based on that, which means you can build complete set of auditing capabilities on top of that. Or for instance, tags. Using tags, you can control lifecycle policies. You can say that which objects get moved to which storage class. Using tags, you can even control access policies to say that this application can only access these data sets which are tagged using these objects. And the tags are mutable. You can change the tags. You can have the tags operate change based on how needs changes. Or if you think about the business insights, what you can get, for example, storage insights can recommend that based on your lifecycle, based on your object access patterns, that you can move this data from one system, from one S3 standard storage class, for example, into standard infrequent storage class, or even to Glacier for archival purposes. Or if you think about it, within a data lake, it's most important, most critical for figuring out many ways for you to bring the data. Because data comes in wide variety of formats, wide variety of sources. For example, you can use Snowmobile, Snowball, to move petabytes or exabytes of data within S3 very efficiently, very effortlessly. Or you can use S3 transfer acceleration, which allows you to move data from remote devices or from other locations at a very high throughput into S3 in a very reliable manner. Or if you think about Kinesis Firehose, for example, which allows you to capture data in real time. So clickstream data sets, event data sets, all of that can land up in S3 much easily. And S3 as a storage has twice as many partner integrations as any other cloud storage vendor out there. If you think about AWS Marketplace today has over 3,500 softwares available which work with S3. These are offered by over 1,100 software partners who have put the solutions in the AWS Marketplace. And all of these features which comes with S3, these are what is good. It's almost fundamentally impossible for you to build them using your own storage. But you get this in a way so you can build your data lake, you can manage your data lake. But building, managing, or storing your data in data lake is just not enough. If you really think about it, one of the biggest reasons, like if you look back in time, why people started using S3 as a data lake or as a way to store the data and process and analyze the data was because it gave you the ability to use the data in place without having to move the data from one system to another system. We all have been through the journey where we had a transactional database where we're storing all of our data sets and then moving them into a data warehouse after doing ETL or processing just to be able to query the data set. But with S3, over the same set of data, now you can run SQL queries using Athena. Using Athena, you can just start with a few clicks in a console, define a table, and start running your SQL queries on ad hocly. With Redshift Spectrum, for example, your Redshift queries can span over your data in Redshift or in S3. It runs the same query seamlessly across either of these data stores. So S3 becomes a fundamental extension of your data warehouse. Or with Amazon EMR, which has been available for many years now, which provide a managed Hadoop framework so you can run jobs like, or frameworks such as Hive, Spark, Pig, MapReduce. All of these technologies, they operate by directly working with the data sitting in S3. You never had to sort of copy data out of S3 into one of these systems just to be able to use it. Have you ever thought about it? For example, when you go to Athena, you just define a table saying that this is the location of the data in S3, and you just run queries on top of it. Or Glue, for example. Glue allows you to catalog your data. It also has crawlers which can discover your data and automatically catalog them in the data catalog. Even from a transformation perspective, what Glue allows you to do is it takes your ETL workflow, generates Python script for you. And these Python scripts, Glue runs them on a scale-out Spark servers. But you don't have to manage any servers. You just write your ETL, generate your ETL workflow, it converts them into Python code, which runs on a Spark servers. But all of these works together. For example, the catalog you create using Glue, you can use the catalog to query the data from Athena, from Spectrum, or even from Amazon EMR. In all of these systems, what is happening is that you're just taking the data, or these are reading the data from S3, processing it, and giving you the result set. But have you ever thought about what really happens in the scenarios? Deep inside, when we run this query, saying that this is my table in S3 and this is my query, what happens in the query? For example, let's think about it. Today, we are a small company, we're a startup. We have 100 customers. We are storing all of the data set in, let's say, one object. My object has one data for all the events generated by those 100 customers. I want today to get data for one customer, so I will just log into a single node cluster somewhere, and I'll say select star from that object or select star from that file where customer ID equal to this. That's great. Tomorrow, let's say that we are very successful, become a big enterprise. Now we have 1 million customers, and I'm storing the same 1 million customers in an object. So if I run a query today, select star from that object where customer ID equal to this, in that case, what's going to happen is that query is going to retrieve the data for all the 1 million customers and then find one single customer out of it. What really happened in this case is your compute now will no longer be able to run on a single node cluster. You probably have to deploy a cluster of 100 nodes, maybe something bigger than that. And in this case, what you're doing is that all of the compute is just reading, scanning, filtering data from S3. In most of the time when we run our queries, we don't think in that manner, right? But this is what essentially happens if you look deep down. And the resultant of which is that your compute scales based on the object size. It does not scale today based on the amount of data you actually want to use for a query. Because in both the cases of the query, I wanted to query one customer. But in one case, I had to use a single node. In another case, I had to use a 100-node cluster just to keep the performance same. So what it really means is that the whole filtering, the scanning, retrieval, which is inbuilt part of any framework, any application which works on top of S3, it's there by design. but we never look into that. That compute part of application, all it's doing is just reading data from S3 to find the bytes you need or to find the data you need. And which means that a whole lot of applications, every application in fact, is doing this heavy lifting and trying to scan, find, and retrieve data from S3. In another case, for example, think about that. What if I would have archived that using lifecycle policies back from S3 to Glacier? And now, due to some reason, I want to find that single customer again. Today, I have to retrieve the entire object. I have to restore the entire object back to S3 and then be able to use it. So while technologies have allowed you to use data in S3 in a very effective, in a many different variety of ways, yet if you look at it, there are situations where the data lake concept allows you to decouple storage and compute, but yet both of them linearly grows. As your data grows, your compute also grows. This is the feedback we constantly heard from customers, saying that while the data lakes are growing, at the same time the compute cluster is also growing. Either the query performance are getting slow, or their processing performance are getting slow, or they have to grow in a larger cluster. So, sorry, I think I forgot to change the slide. But with that, we announced today Amazon S3 Select and Amazon Glacier Select. Both of these features allow you to retrieve the needed data, the data you want, or the data your workflow needs based on a simple SQL expression from S3, from the object in S3, or from an archive in Glacier. The way they work is they both are available as API. They work on a single object or a single archive. For similar to what you do with get, what you can say is that from a single object or from a single archive, get my data. Second, because of the way we run it, when you call this API to say that give me the data you want, we process the data as close as we can to the storage, which means that we are avoiding all the network hop of, for example, get a data out of S3 back into some compute layer and then processing it. We are directly reading data from the storage, which means that we can run this processing faster than what you can do outside of S3 in every single case. Not only that, by retrieving less data, or by allowing you to use S3 Select to retrieve the data you only need from an object, what happens is that first you save money on the compute, of course, and we'll take a look into that how. But second part, in certain situations, for example, like Glacier, when you're trying to restore the data set, you also save on retrieval cost. The less amount of data you retrieve, the more you save on both compute and retrieval cost. My colleague Rashim, who is working with Glacier Select, he will talk about that. How does this work with Glacier in terms of retrieval, for example? So that's just a general introduction. I mean, I think on how these features work, what are the features intended for. With that said, now we're going to take a look into each of these features on an individual basis. So let's start with Amazon S3 Select first. So as we mentioned, that Amazon S3 Select works exactly like a GET request. If you know, a GET request is an API using which you can read your data. It's like saying that give me that object, or give me the contents of the object. So you call a GET, you give it an object name, and it streams the entire byte of the objects back to you in a sort of synchronous response. Select works exactly in the same manner, but the difference being that instead of saying that give me the object, what you say is that give me the data from the object which matches this criteria. The criteria what you specify in this case is a SQL expression, and we'll talk about that a bit further. In addition, we also have S3 Select available from Java and Python SDK. Python SDK because a lot of you guys like Lambda, and we will talk about the Lambda use case. And Java SDK just because a lot of these frameworks, for example, Presto, Hive, MapReduce, all they operate on the Java realm, and other applications too. So we talked about the criteria. So you say get with the criteria, and the criteria is specified using SQL. The reason we chose SQL is because, like many of us, if anybody who's worked in data processing, data analytics, SQL is something we all understand. SQL is something we all know. So we think there are applications of these features beyond what we can imagine. And I'm fairly sure if you look back in history, we never imagined that how S3 will be used with, for example, Hadoop kind of use cases for big data processing. And we hope that some of the use cases will like something you guys or you as a customer will think about it and let us know that this is what it can enable, this is what it can help you do. So if you take a look back into the SQL, the API, you specify 3 things. The first thing is input serialization. What the input serialization does is it helps us parse the object content into sort of a records or fields. You can think of it as a table in a database. So based on that, if you say that your data is CSV, we will take the CSV, pass that into records and fields. If you say data is a JSON, based on the whatever JSON expression you had, for example, saying that select key.value, we'll pass that into, again, a tabular format, which is record in fields. We do support gzip compression. And the ellipses here denote that we are in preview as of today. And the ellipses denote that we are going to support more features and more compressions as we go along from now. And then you can also specify an output specification. And the output specification says that how do you want the data back. And if you really think about it for a moment, what it allows you to do, using the Select API, you can provide a single common way to retrieve data set in a common format, irrespective of how you store your data. You could store your data in CSV, JSON, could be any log format, could be Parquet, ORC, Avro, yet you can construct then, or you can extract the data in a common format, which means every single downstream application from S3 now can be very efficiently optimized to use that format. You don't have to write applications which work in many formats, for instance. So in between, there is SQL. So you get the input, you apply the SQL expression on top of it, and you deliver the results back as a byte stream, which is the SQL. In SQL, we support select, which is used for projection. So imagine that you have a delimited file, a CSV. So we can say that select column 1 or column 2. Not only that, you could do things like imagining first column 1 is first name and column 2 is last name. So now you can say select full name, which is a concatenation of first name plus last name. So you can say that select full name from my object. The where clause, which is basically used for the predicate. So now you can, for example, if you want the name of the customers from the state California, so you can say that select full name from this object where state equal to California. The from clause is basically a filler. In this case, in the SQL expression, actually, you always write from S3 object. And the reason for that is that because the compatibility with the GET API, the actual name of the object, you pass in with the parameter, another parameter called key. In the key, you actually specify the object name, right? But within the SQL expression, you always say from S3 object. Now, we also do support some fundamental data types, string, Boolean, decimal, integer, float, and so on. In many of these cases, for example, in CSV, there's no concept of a data type. You never say that in CSV, my field 1 is an integer or something like that. It just is stored as a string. So by default, we think everything is a string in CSV. It's not that case with JSON because JSON does have some concept of a data type. We do use the same concept as a standard JSON. So for example, what if you wanted to say that, give me the name of the customers where zip code equal to 98115? So you cannot say that from that CSV file, select full name from CSV or from S3 object where zip code equal to 98109. Because in one hand, zip code is assumed to be a string, but you're giving an integer value to it to compare. But what you could do in that case is you could say select full name from this S3 object where cast zip code as integer equal to 98109. In that case, what it means is that where there's a lack of data type, everything is assumed to be a string, but you're going to apply the cast function to convert into the appropriate data type. From an operator's perspective, we support conditional operators. So we talked about some of them already, like equal, less than, greater than, not equal, and so on and so forth. Math operators, so we can do addition, subtraction, modulo, division, multiplication, etc. From logical operators, so you can combine multiple conditions in the where clause. So you can say that where state equal to California and zip code equal to 98115 or 95 something. And or basically the same concept of Boolean expressions, and or not. And within the string, you can do substring matching, or you can do partial matches. For example, you can say that select full name where last name begins with A or something of that sort. We talked about some of the functions already. For example, the cast function. Within a string, you can do substring, upper, lower, and all of that. We can also do some math functions, for example, floor, ceiling, absolute, and stuff. And then you can do aggregates such as sum, count, min, max, etc. So if you guys are, all of us, I think, in this room probably are familiar with SQL. There are some big things you will understand are missing here, like group by, join. What was that? Count. Yeah, count. Well, count is there in aggregate. I didn't mention it. Group by and joins and analytical functions like rank, window functions. And the reason for that is this is not a SQL syntax which is used for analytical queries. We are using SQL as a way for you to express what data set you want out of an object. The intention is very different. The intention of SQL in Athena or Spectrum is to provide you full spectrum or full wide variety of all the SQL capabilities so you can run your analytical queries. But in this case, our intention is for you to express what data you want to retrieve out of an object. And this is per object. This is not across a group of objects. This is not across a prefix, not across a bucket. Every request runs on a single object in there. So let's think about what we can do with it. For example, let's say that we have a log file. And in that log file, I want to print the first column if the value of fourth column equal to some value, let's say x. In general, how would we do it? We'll just get the object, we'll say get object from S3, and then we'll run some tool which is like grep or something similar on that to filter the data, or maybe a script. If there are a lot of objects, we're probably going to use a cluster. Maybe run it using MapReduce, streaming MapReduce job, maybe run it using Spark, maybe run it something else. But with ST Select, now you can just convert the work which is done by awk into something as select request. So now you can say that select object 1 where object 4 value equal to x. And even if you have 10,000 requests in this case, what you could do is you could run those 10,000 requests just right from your laptop. You can run 10,000 parallel S3 select requests in parallel, which will basically get the result back to you without having the need for the cluster. Because in this case, all you're doing is we're just issuing S3 select request. Versus in the previous case, you actually are downloading all the data and doing all the processing. So let's just take a quick example or quick demo. Okay. So if you focus on the first part of the demo, which is before the with ST Select in gray, in the first part of the script, this is a simple Python script. What it's doing is it's downloading a file called airportcodes.csv. It's basically a CSV file which has the first column as the airport code, which is like, for example, LAS. Second column as the name of the airport, like McCarran International, followed by latitude, longitude, and hence on. So in the first section, what it's doing is that it's getting the data CSV, the entire data from the CSV object, splitting that object by new line into like lines, into records, splitting each record by comma because it's a CSV file, and then it has basically a data in a format. And then it's saying that if data 0 equal to LAS, which is that first field equal to LAS, then print the name of the airport, which is the next field. And if you look down below, which is the with ST Select part, in that what it's doing is that it's saying that now instead of doing all of that work, just run this query on that object or run this SQL expression. And the expression here is basically saying that select object 2 where object equal to LAS. So that's the code I already have ran, so I'm just going to try to show you that. And it might be a little hard to see at the back, but at least you could see the code and you probably got the idea. So if you look at it in this query, it's not the same code which I showed you, but in this query, what I'm trying to do is print all the first and the second columns without a filter. And if you look at it, at the bottom it says, with ST Select, it took 0.32 seconds. And without ST Select, it took, I think, 1.89 seconds. So just by rough calculation, it's almost 6 times faster. So running the same same sort of processing, running the same sort of query with S3 Select, just right from my laptop, I was able to run this 6x faster, which is almost 500% faster. Let's look at the second part, for example. And in this case, I'm actually running the query or example I showed you, which is this one, that get the data and print the object, print the second column where the first column value equal to LAS. Is this the one? No, this is not. So if I run this, and now you can see both the queries are both the scripts printed the same value, which is McCarran International Airport, which is the name of the LAS airport. And with S3 Select, it ran in 0.27 seconds, and without S3 Select, it took over 2 seconds. That's almost an improvement of 10 times. Now, a question, why did it run only 5 to 6 times faster in the previous case? Why 10 times in the next case? Because if you think about it, in the first case, I'm retrieving 2 columns for every single row, which means that my file almost, I think, has 4 to 5 columns. I don't remember exactly, but if you're retrieving 50% of the data. In the second query, I'm retrieving only very few data, hardly a name of the airport. I'm retrieving less than 1% of the data, which means that the less data you retrieve, the more faster it becomes. And if you think about the applications of this, are you back? Yeah. If you really think about the applications of this, one of the most important thing which comes to our mind is Lambda, serverless applications. Why? Because a serverless application, a single Lambda compute function provides you with limited compute. And you want to optimize that compute to do the most important thing. Do I really want to use the compute to do all of this processing of lifting the data, entire object from S3, process it, transform it, and then find what I need? What if, for example, you wanted to create a notification saying that if a count of errors in my log file becomes higher than X, then trigger a notification? A typical way we will do that with Lambda is that we'll say retrieve the entire object, process it, split it into lines, do a line count where line has error field or something like that. Which means that your Lambda, in certain cases, might not even be able to process the entire data. Then you have to think about how to do distributed Lambda, how to use some other application. But with S3 Select, you can just run a single select request. And as we mentioned, that we run the same select request within S3, which means it will run faster, cheaper, and more efficiently. From a practical perspective, if you really think about it, some of you guys might have seen this example, which is a serverless MapReduce using Lambda. Well, this is a very ingenious case. The author, who's a colleague of ours, what he has done is he's basically created a distributed framework in which you're running map and reduce function as Lambda functions. And he's coordinating them by writing like their state back in S3, and they're coordinating the work around there. So what this function is doing on the left-hand side is, from the Wikistats data file, it's saying that for the IP addresses, tell me the amount of revenue I generated. So what it's doing is reading the entire object from S3, again splitting them by new line, again splitting them based on a comma, finding the IP address, which I think is the first field, and then doing a substring on that, which is the last line you can see in red, source IP equal to data 0 of 8. What it just means is saying that take the first 8 characters of that field. And then it's doing all the calculation back of it. But on the other side, if you look at it, all the red part, which is the main processing of it, it can be just replaced with the S3 Select query or expression in this case, which says that select substring of this object, which is the 1 to 8 characters, and the second field, which is the revenue. By just doing this change in the Lambda, in this serverless MapReduce functions, we saw that there was improvement of 2x. But the most important part was that the cost went down by 80%, which means that this Lambda function, by just replacing this, was able to run 100% faster at 20% of the cost. So you were able to save 80% of the cost just by doing this small change. But really, if you think about it, with big data applications, this again quantifies, or this magnifies. We were talking about a small Lambda example, but think about you're running a query on a large, very large data set, a petabyte, a terabyte data set. What happens in that case? As you mentioned earlier, that whole filtering, that whole scanning happens within your application. With ST Select, that filtering just becomes a pass-through, which means not only the compute footprint, the compute required by your application reduces, but it becomes simpler, easier to operate. So if you think about it, you can get up to 400% faster and up to 80% cheaper cost on your compute just by using ST Select for these queries. And just to make it easier, because many of you guys might be using Presto, I don't know. Can I see how many of you guys use Presto? A lot many this side. Are you guys like sort of congregating on Presto side or something? No. Okay. And many of you guys use Presto to query data from S3. It's a quite popular tool. In fact, Amazon Athena is based on this. Amazon Athena is, in fact, a managed Presto. So what in this case happens is we created a connector. So that connector, what it does is it works with the existing queries. It works with the existing high meta store, which means you don't have to change anything. You don't have to remove anything. It just works as is. All you do is just run a Presto query. Once you install the connector, you even provide a bootstrap action for Amazon EMR. So folks who are using Amazon EMR, they can quickly bootstrap this connector on the Presto cluster. And after that, you don't have to change anything in your query. You don't have to redefine your meta store. You don't have to do anything. You just run your queries, and everything works exactly as is. What the connector does is once you run a query, Presto generates a plan. It looks at the plan, figures out what are the predicates, and converts them into ST Select request, and transparently uses ST Select for the predicate evaluation. So if you quickly look, let's quickly look at a demo. Let me make sure. So I am just logging inside an Amazon EMR cluster, and okay, cool. So this is the Amazon EMR cluster which I've been running, and this has already been bootstrapped with the Presto, the connector we created for Presto. And the query which I'm going to run in this case is, if I just do a cat, this is the query I'm running. And for readability, let me quickly find. This is the query which I'm running. And if you actually remember in Andy's keynote, Andy talked about we are running a complex Presto query, which is scanning the largest table over a standard TPC-DS data set. This is the query which is running the largest table in the TPC-DS data set. It's a pretty complicated query. It has 6 subqueries, it has aggregation, it has where clause, it has all the filtering. The reason we chose this query is because this query runs over the largest table, yet only uses less than 1% of the data. So you can understand that, you can see how this works and what impact does it have to a Presto kind of use case, or any sort of analytical kind of use case. So for the guys who cannot see in the back, what I'm doing is I'm just running the same query which I showed you. But one of the things, when you install a Presto connector on the Amazon EMR cluster, it enables a session property in Presto, which is basically S3 optimized select enabled. By setting it to true, you're making the connector use ST Select. By setting it to false, you will make it not use ST Select and just use the traditional method. In both the cases, whether you want to use ST Select or not use ST Select, you don't have to change anything. You don't have to restart your cluster. You don't have to install, remove anything. All you can do is just set this flag to true or false, and accordingly you can change whether it's running with S3 or without ST Select. So when I run it with ST Select, what really happens in this case is that the query, the plan gets converted into ST Select request, and it comes back in somewhere around 6 seconds on the elapsed time. On my laptop, it says that it took 6 seconds end to end. When I run it without ST Select, same query, nothing changes, exactly the same environment, exactly the same setup. All I've done is change the flag to say that don't use ST Select. And let's quickly go back to the Presto console. You probably can see that running on that side. So you can see the first query which is there, which took around 6.1 seconds, and the second one is still running, because in this case it's trying to retrieve all that data set from S3 and then doing all the scanning, filtering, and processing. It does take a little while, not that much, promise. It's less than like 35 seconds or something like that. But you get the idea, right? You can use this query, or you can use ST Select Connector to run query from any scale. OK, so it came back. So on the top, you can see it took 34 seconds. And the bottom one, you can see it took 6.10 seconds. But very interesting, if you look on the other side. So some of you guys who know Presto, on the same row where it says 34 second, you can sort of see an icon towards the end which says 3.85 minute. And on the bottom, you can say 6.80 second. And what it means, or what Presto is trying to say in this case, that the query without ST Select consumed 3.85 minutes of the CPU time. The query with ST Select consumed 6.80 seconds of the CPU time. So we went from minutes to seconds. Look at the memory footprint, which is just below that column, which says the query without ST Select took almost a terabyte. Oh, does it say petabyte? Something wrong. All right, never mind. I will have to look at it again. Sorry about that. Maybe something is not right here. We need to rework on that. So let me get back to presentation. It always happens in demos, right? And that's why I had this slide pre, because I knew that it's going to happen. So you can look at that. In the other case, the memory footprint actually goes down from a terabyte to a gigabyte. So I'm not sure what's happening there. We'll check on that for sure. But I can assure you that's not the case. That's not what's going to happen. But you get the idea, right? So that you're able to run the query 4 times faster at 1/48 of the CPU requirements, roughly, right? So you can see how it's going to help you in the same. So we talked about Lambda, where we were able to show example where it showed you 80% of the cost. And here we're talking about example which shows you that it's going to run a 400% faster. Well, all of these applications can run at that speed. So in fact, many of you, I mean, as you asked that how many use Presto, I think roughly 20%. The rest of 80% of you use any of one of these tools available, or probably something different. So our intention is to work so that Amazon Athena, Amazon EMR, Amazon Retrieval Spectrum, they all support ST Select. And not only that, partners such as Cloudera, Databricks, and Hortonworks, they also will support ST Select. So you can run the same workload from Impala, Spark, Hive, or many other tools and get the efficiency out of it. So just to recap, and while I'm recapping it, you actually guys can go and apply the preview right now if you want to. We intend to whitelist users today, start whitelisting them today. So if you think about it, we support, again to recap, we support CSV and JSON format with more to come later. We support gzip compression. In our preview, we do not support encryption at rest, but rest assured we'll support encryption during our GA. We do support UTF-8 encoding. We have Python, Java SDK, and Presto Connector available, with more to come again. And then we are available in our part of preview in Virginia, Ohio, Oregon, Dublin, and Singapore. So with that, I would like to invite my colleague Rashim to talk about Glacier Select. Thank you.
Thanks, Rahul. You want to take out your laptop? I'm going to first make sure my laptop gets connected, and then I'll start.
You get props for taking bare left demos.
That's okay.
Okay, great. So hi, everybody. My name is Rashim Gupta. I'm a PM for Amazon Glacier, and I'm here to talk about Glacier Select. So how many of you use Glacier today? So I see 5 to 10%. So I'm going to spend a couple of slides on Glacier first, and then we can talk about what Glacier Select is. So Amazon Glacier is an extremely low-cost archival storage service with pricing starting from 0.4 cents per GB per month. Last year at reInvent, we introduced 2 new retrieval tiers, which allowed you to not just store your data in Glacier, but retrieve it within a few minutes. And this was a game changer, because if you are traditionally using tapes, you know it can take you from days to weeks to retrieve your data. But with this, with the new retrieval features, you can now get your data in case of urgent need in a few minutes. and Glacier Select actually uses it. So I'm going to spend some more slides on that. In terms of durability, Glacier has 11 nines of durability, similar to S3 Select. What that means mathematically is if you have 10,000 files stored in Glacier, the probability of Glacier losing one is after 10 million years. So it's super, super low. And even if you, for those of you, again, using tape, the common paradigm is to use 2 tapes in separate locations. And we actually work with a customer to model out the durability. And the best durability you can get with 2 tapes in separate locations is 5 nines. So Glacier offers you 5 magnitudes of higher durability when you store data with Glacier. Coming to encryption, all data is encrypted at rest in Glacier. Even if you encrypt your data, we will encrypt it again to make sure it's secure. And finally, if you look at the features, Glacier offers compliance, data management, cost management, audit logging. And all these features make it easy for you to see how storage is being used, and also for cost auditing. So the key takeaway here is Glacier is not just a low-cost archival storage service, but can meet a variety of archival use cases. And Glacier Select is adding more to that. So if you look at the AWS storage classes, we give you a variety of choices, starting from Amazon S3 Standard, which is used for active data, to Amazon S3 Standard Infrequent Access, which is for more infrequently accessed data, and finally Glacier, which is for archival data. One of the common patterns we see from customers is they bring their data to S3, keep it there for a certain period of time, weeks, months, and then as the data is used less and less, they move it to across these different storage classes to save on costs. So AWS offers a lifecycle policy management where you can actually define a template of how often you want this to happen automatically. So your data comes into S3 and you say, after a month, move it to SIA, and after maybe 6 months, move it to Glacier. And all this will happen automatically. So the takeaway here is the data that's coming to Glacier can either come directly if you upload it to Glacier, or it can come through S3 through lifecycle policy management. So in either of the 2 cases, you're able to use Glacier. I did talk about these retrieval tiers. As I mentioned, we have 3 retrieval tiers in Glacier: expedited, standard, and bulk. So if you have a need of retrieving your data, you can choose one of these 3 tiers, and depending on how soon you want it, you can get back your data. This expedited and bulk were introduced last year, and all 3 tiers are quite popular. Customers love being able to retrieve their data, especially if you have an urgent need. You can retrieve it in 1 to 5 minutes. Okay, now I think that was a good intro of Glacier. Let's talk about Glacier Select. So what is Glacier Select? Glacier Select is a new feature that was launched today, which allows you to select your relevant contents from a Glacier archive rather than restoring the entire object. So similar to S3 Select, we use a SQL expression where you provide a select clause to tell us which columns you want, and a where clause, which provides the filtering condition. We also use the same familiar semantics that we have for restore. So if you have been using restore in Glacier already, Glacier Select is just extending that API to add more arguments to it, to make it pretty simple for you to start using it. And I'm going to show that example in a few slides. It's also integrated with AWS SDK and CLI. One thing to note is there is no console access yet. It is supposed to be used programmatically. But all the tools you use today for Glacier will work with Glacier Select. So how do you use Glacier Select? Like which API? As I mentioned a few slides before, there are 2 ways to load your data into Glacier. You can either load your data directly into Glacier using the Glacier API, and that's shown on the left, or you can upload your data to S3 and have lifecycle policy management move it to Glacier. So, and from that point on, if you want to access your data stored in Glacier through lifecycle policy management, you'll use S3 API. So depending on how your data landed into Glacier, you use either the Glacier API or S3 API, and Glacier Select works with both of these APIs, depending on how you brought in your data. So I did mention briefly that we've extended the current restore object API argument. So if you look at the top row here, today if you were to restore an object from Glacier, you would provide us 2 arguments. You would provide an object ID, which you want to restore, and you would provide us a tier. Like I mentioned, the tier can be bulk, standard, or expedited. With these 2 arguments, we can get the object, read the object in Glacier, and give it back to you. For Glacier Select, we added 3 more optional arguments. If you do not, and these are shown at the bottom in the second row. If you do not provide these, it's a restore job. If you provide these, it's a Glacier Select job. The 3 optional arguments that are needed for Glacier Select are firstly the SQL query, which actually describes what you want to filter. The output S3 location, which is a location of an S3 bucket that you own and have permissions to, and where the output will be written to. And finally, an SNS topic, which you can subscribe so that when a job completes, you are notified. The SNS topic and output S3 location are actually quite powerful, which are not available in Restore today. If you didn't have the SNS topic, you have to keep polling to checking if the results are there or not. So, and that's something customers today have to do with Restore, but with Glacier Select, you do not have to do it. You can just subscribe to the topic and you'll be notified. So it saves a lot of cycles on your application. Also with the output S3 location, this is now a bucket you own, and so it gives you much more control of the output, how you want to use it, if you want to integrate it with other applications, define more fine granulated access control, all that is possible. So this is an example of how the steps you would have to take with and without Glacier Select. So this was similar to the example that my colleague Rahul showed. If you have a log file where you want to print the first column, where the 4th column matches ID, for example, if this was your task and the archive was in Glacier, if you didn't have Glacier Select, you would first have to restore this object into S3. You would then have to call a get request, get object in S3, and load it into like an EC2 or an EMR cluster or something, run it there, and get your results back. So it's a lot of steps and a lot of cost. You have to pay for the restore cost. You have to pay for the compute cost. Now that we have Glacier Select, you can just call the restore object API and pass in the optional SQL query, which will filter the data, and it will reduce the amount of data that comes back. It's written to S3, and then you can just call get object and get your result. So it's much simpler workflow, and it's much cheaper. This slide shows you the flow of messages between your application, Glacier, and S3. So your application can call the Glacier Select APIs with an archive ID, the SQL query, and the tier, and also an S3 bucket to write the output. Once this is received by Glacier, the first thing Glacier does is it checks that you actually, the SQL query is well formed. Secondly, you actually have permissions to read the data from Glacier, and you also have permissions to write it into the output bucket. If any of these fail, the query fails. Otherwise, it sends a 200 OK. From that point on, depending on the tier you chose, Glacier will schedule the reading and the filtering. And once the job is complete, you write the output to S3, and then notify you using SNS. From that point on, you can read the data from S3. So some Glacier Select use cases are listed here. I'm sure there are more. But we have a lot of customers in ad tech, and they use their clickstream logs to measure, to collect, calculate billing for their customers. And what they end up doing is, again, they have for a few months initially, they load their data in S3. As the data gets older, they move it to Glacier to cut costs. So now with this feature, before Glacier Select, if they had like billing inquiries, they would actually have to restore the entire clickstream logs and search for the particular users, particular customer. With this feature, now they can just run a Glacier Select query, get the relevant records, and provide the inquiry back to the customer. We also have customers in financial space who use Glacier a lot. We actually have a feature called vault log, which enables them for write-only, read-many, which is a requirement in financial regulations. And for them, if they can now use this feature if they have any audits that they need to perform. So they can use Glacier Select to quickly get the answers if required. And finally, we have a lot of customers who are using S3 and writing their own application to build training models for machine learning. But as these training models get bigger and bigger, we see some of them moving these training models to Glacier, because you usually run these training models once every 3 months or once every 6 months. And in this particular scenario, Glacier Select will be quite useful because you don't have to, again, get the entire set of training models to S3 and run this heavyweight lifting. You can get only the relevant set and run it. Again, we expect, I'm sure there are more use cases, but these are the ones that customers have told us they would like to use Glacier Select for. Going into the features supported, we support on the input side, we support anything delimited. So CSVs, TSV, PSV, anything, you can provide any kind of a delimiter. And on the output side, it's also any delimited supported text. The input delimiter can be different than the output. And this is, again, goes back to what Rahul was talking about, living the data lake dream, because you can have different formats on the input and have the same output format when you're reading data. In terms of encryption, we support server-side encryption, specifically SSE KMS and SSE S3. And then SQL clauses, we support select for selecting the columns from, you always write from archive in Glacier, and the archive refers to the archive ID you've specified. I'll show you that in an example. And the where is the filtering conditions. Data types, we support pretty much all the fundamental data types. Default is string. Operators, we support conditional, math, logical, and string operators. And you can also cast. We provide functions like cast and string to do SQL, to provide cast functions. I would want to call out, again, similar to S3 Select, we do not support join, do not support group by, because the goal of this feature is to do filtering and provide you relevant data. It's not a replacement for analytical engines. So at this point, I'm going to do a quick demo. And hopefully it works. A little scared from before. OK, so what I want to show, and I'm going to first run it, because this is Glacier. It takes a few minutes. It's not instant. But what I'm running, and I'll explain to you what I'm running. So this is my input data. OK, it's not showing up, sorry. So what I did is I ran the query here first, just so we have a head start on that. And this is my input data. It's and airports, it's just the same data set that Rahul was showing you, which is a list of all the airports. All the airports in a region, how many airports are there? I initially thought Las Vegas only had one, but apparently there are more. And let's use Glacier Select to find out how many. So this archive file has 52,000 records, right? So there are 52,000 records. This is stored in Glacier. What I want to do is run a query in Glacier and say, give me all the airports or helipads or what have you in the Las Vegas region. So so what I did is I wrote a quick Python script, which is extending the restore API to use Glacier Select. So what I define here is I say the type is select. I provide the archive ID, which is the archive ID of the actual object stored in Glacier. I say tier is expedited. Expedited, again, should respond in under 5 minutes. I can also do standard and bulk. And then I say the input serialization is CSV. I provide my SQL clause, a SQL expression here. If you notice, it says select star from archive, and this will always be archive, but it's referring to this archive ID, where municipality is Las Vegas. I was able to give this column name, header name, because I used another field here which says file header info use. So what this is telling Glacier is to use the first row as the name of the header. If I did not have it, I would actually have to say underscore column number, like underscore 10. And then the output serialization, I say is CSV. It could be any other TSV, PSV. I also provide an output location. This is a bucket. my bucket, and the prefix. So I ran this. When I run this, I get a job ID. You can see it's E0J. Let's just remember those three. And now what I'm going to do is I'm going to go to my S3 bucket, which I provided in the job, and look for this folder, E0J. And it's there. And I see that this job started at 7:53, so about 3 minutes ago, and I already have a results folder. If I go to the results folder and I download it, let me do that. So within 3 minutes, this job completed, which is good. And I'm going to open it and see the results. So let's see how many airports there are. Does anybody want to take a guess while I'm opening this? 23. So if you cannot get a flight out tomorrow or Friday, you have 22 other options. So I can share this data set with you if you'd like to know where to go. OK, so with that, let's talk about pricing. The way we price this is we charge you on data scanned, on data return, and a request cost. So what this means is when you send a Glacier Select request, you are charged for the total amount of data scanned, and then the amount of data that was returned to you. So if you think about it, hypothetically, if you had a 1 gigabyte object and you only return 1 megabyte, if you were to restore it, that 1 gigabyte would cost you 3 cents in expedited. And then you would have to pay for an EC2 cluster, what have you, to run the analysis. With Glacier Select, if you do the same thing, we will charge you 2 cents for the scanning. And since you're only returning 1 megabyte, it's minimal cost. So essentially, already using Glacier Select is cheaper than restoring the entire object. So it's a 33% savings right there, in spite of us doing the compute for you. In addition, like Rahul mentioned, you can save up to 80% in compute costs, which you don't have to do anymore. So it's a lot of savings for you. So not only it saves you steps, it's a lot of convenience, it's cheap. So that's how it's priced. Another announcement is in 2018, Amazon Athena will integrate with Glacier Select. And with this, you will be able to query Glacier data directly in Athena. You will also be able to use Glacier as a data source in the SQL queries that you can write in Athena. So Glacier Select is in GA starting today. We support for all comma separated, any delimiter separated files. We support SSE encryption, UTF-8 encoding, and we work with SDK and CLI. Athena will come next year. It's available in all commercial regions where Glacier exists today. And with this, I want to go back to Andy's keynote announcement this morning. AWS is making your data lake simpler, faster, and cheaper. With the announcements today of Amazon Glacier Select and S3 Select, you'll be able to use them with a lot more engines and applications. You can already use Athena, Redshift, Spectrum, EMR, and Lambda with S3. But with S3 Select, it just becomes faster and cheaper. We're also seeing more and more of these engines will be integrating with Glacier Select over time. You'll also see third-party ISVs and custom applications, which will build to leverage these features. There are 2 sessions that already happened this afternoon.
No.
But you might find it more useful if you can go back and check on YouTube I don't know if there was. I think there might be more sessions we can follow up.
They both are tomorrow at the time mentioned.
Oh, they both are tomorrow? These 2? Yeah. OK.
Yeah.
OK, at this point, any questions for S3 Select or Glacier Select?
Yeah.
There we go. Just wanted to validate no support for JSON in Glacier Select.
That's correct. That's high on our list, but not right now.
So 2 questions. The first one was about JSON data. So do you support hierarchical queries in any way?
What was that?
Like, do you support queries on hierarchical data, like arrays or nested records, things like that?
No. At this moment, I think we support only the first level of JSON. There is a way you could sort of like project a nested scheme out of JSON and then run first level queries on that. I think our API specification, which is public, does talk about how you can do that.
Right. And is there any plan to support like Avro or Presto in the future? Or Parquet, rather?
Yes, yeah. We do have plans to support Avro, Parquet, and ORC. If there's a request, feel free to send your feedback to us, and we can definitely work on that.
Okay. And also you have, I saw that you read compression, so gzip, I assume Snappy probably at some point in the future or now?
More compression, more compression codecs, and more formats, definitely, yes.
So that's on the input, but then I guess the data that you're sending me is already uncompressed. Are you ever going to support compressing the data when you send it to me?
Yes, we are. I mean, and that's the reason why we're in preview, because we want to get the feedback from you and what's more important and what's more required for your customer use cases, so we can collect that and build that at support.
And this is just the start, right? You'll see more and more innovation around these features.
Cool. Thanks a lot.
Yeah, thank you.
Hey, so I get that it's still in preview, but you kind of gave some hints into what's coming up.
Yeah.
So for the current EMR support, just to clarify, it's just Presto.
In preview, yes. Today it's just Presto.
And when you say there's upcoming support from other distributions, does that imply like MapReduce, Tez, Impala, Spark? What does that mean that the other distributions will support it?
It's sort of a question which I don't think I can answer right now, but we can definitely follow up on that. What we would think that the support will be limited to the most of the analytical queries and other applications also, but that's what we would think, but we can definitely follow up and confirm on that.
Okay. And then did the current Presto connector support partition tables already?
Yes.
Okay.
Yeah, it works with partition table. In fact, you can run a query which is, for example, a non-separated format, let's say today like Parquet, and another one is a CSV or JSON. You can run a join across that, partition, non-partition, doesn't matter. So yeah.
Thank you.
Sure. And by the way, just like if you apply for preview, you also will get the opportunity to participate in a private forum, and you'll get access to the feedback email where you can send all these requests of any other thing you have. So.
All right, so building on the Presto query, we have Presto up and running in production today. So how does this S3 select automatically get into our production?
What you will need to do for that is you will need to take the connector what we have, which is available as a part of the preview, and you need to install that connector or put the connector on the Presto. So if you know about Presto, it works on a plugin interface.
Should we?
So you're just going to install a new Hive connector plugin, and then after that you can just get the same thing.
And
So I think we're going to take questions right here at the podium because we have to unhook the mics and stuff.
Yeah.